All right, y'all. So we're gonna get started. Just a quick disclaimer: I am feeling a little bit under the weather today, so I'll apologize if I don't sound really clear. But I'll try my best to give a good lecture. Um, so yeah, just a quick announcement. A3 is again due tomorrow night. There were a lot of issues that you guys had with CocoaPods. So I believe that I tried to replicate it and was able to replicate the issue, and then I provided like a solution to it. So there should be some ed discussion posts about it. But if y'all are still having issues installing CocoaPods, then just feel free to make it a post on ed discussion, and we'll try to respond and help y'all as quick as possible. But then again, you don't really need CocoaPods until after the midpoint submission. So if there are any errors with the starter code about not having this module, then you could just simply just comment it out. That's because this up to the midpoint it doesn't require any backend or any networking, so you don't really need CocoaPods yet. Okay, are there any questions about announcements? Okay, just to recap, last lecture we discussed a UI collection view. So the difference between a UI collection view versus a UI table view, we know that the init function of a UI collection view is a tad bit different from a UI table view. And then we also realized that we also need a flow layout. So a table view, you don't really need a flow layout, whereas in a collection view, you do need to define a flow layout. And then whenever you create this UI collection view object, you need to give it a flow layout. Additionally, we also have to conform to this delegate called UI collection view delegate flow layout, in which there's a function called size for item mats that returns a CG size. In other words, it's a width and height for each item or each cell in a collection view. And then again, the terminology between a table view versus a collection view. In a collection view, we use items instead of rows. Are there any questions? All right, so today's lecture, as well as Wednesday's lecture, will be the most important lectures that you'll learn in this course. That's because we're actually going to be teaching y'all how to connect your app into the internet. So, with the hack challenge, you'll be working with people on the backend course. And so in order to communicate from the front end with the backend, you'll be needing to use HTTP requests. So, this lecture, Wednesday's lecture, will go over how to do that.
Okay, so yeah, as been said, today we're actually, we're discussing how to connect what we've written so far with what people in the backend course are writing. So as of now, all of the projects you've done and all of the demos have been using hard-coded data. So in A2, for the profile, you're using strings and hard-coded images that you were putting and dragging into the assets file. Even in A3 so far, when you're creating posts, you're doing something that's called creating dummy data. So in this case, you're actually creating the posts themselves rather than fetching them from the internet, which is what you would usually do when you're doing app development. So this is sort of where HTTP requests come in handy. So before we go into how the request structure works, we want to make sure you understand what a client and a server is. So a client is a device or software that requests a service, and a server is a device or software that responds to that client with a service. So in the course so far, the clients that we have been using, I guess, have been the iPhone or the iOS app that you're developing. And then in order to actually retrieve data, we actually need to make a request to the server. And then that server will give us a response back that either being data or some error in case, either the data doesn't exist or we formatted our request incorrectly. So that's sort of how our front end ties into the back end here. So this sort of connection is what we're going to cover in today's lecture. And to again reiterate, the client sends a request, which is the iOS app, and the server responds, which is the backend that you will probably be collaborating with. So specifically, what is an HTTP request? So HTTP stands for Hypertext Transfer Protocol, and it is a client to server protocol, meaning an HTTP request is a method that we use to communicate between a client and a server. So this is the format of the protocol that you would be using to communicate between your iOS app and the backend that you would be using. So common request types come in GET, POST, put and delete. So the names are pretty self-explanatory there of what they do, but specifically in this course, we'll only focus on get and post, which is getting data from the backend, as well as posting data to the backend. So when a client sends a request and the server responds with either data as well as a status code. Sometimes it doesn't give you back the data, and in that case, most of the time, there's either an error or the request itself doesn't give you any data back. So here are some examples of error codes that you may get. The X's represent other numbers that could be there, but usually we have 100 through the 500 range, and 200 means good, and 400 and 500 you could usually associate with something bad. So 100 and 200 errors. So 100 is informational. 200 is usually good because that indicates success. 300 is something you won't really encounter in this class. But more importantly, the errors that you may get. So when you make a request and you get a 400 or a 500 error, usually means something went wrong at that request, or something's wrong with the front end or the back end. So usually when we get a 400 error, it means that we've done something wrong. We've either incorrectly accessed something or given the back end something that it can't process. Usually when we get a 500 error, that's usually kind of good news for you because that means you don't have to fix anything. Usually means the backend's fault. Not always, but most of the time, if you get a 500 error, it usually means the backend's down or something like that. So yeah, so that's what the errors represent. So keep in mind, this may be important to debugging later on. So when we're actually making these requests, the backend will be giving you these errors, and based on the error number, you should really know what sort of error is happening. So 200 means everything's good, 400 means you've done something wrong, or 500 means either the backend is wrong or you've made the request itself has been incorrect. So the language that we use to actually communicate between the front end and the back end is JSON, or JavaScript Object Notation, and it's a text-based format that is language independent. So it doesn't matter what language you're coding in, JSON, this JSON string format will always be the same. So in this case in Swift, we're using the JSON format to sort of store data and use that language in that format to send data to the backend. So keep in mind how we have sort of structs in Swift. This is sort of the equivalent of that. We're trying to convert our structs in order to into this JSON structure so that we can send it to the backend. So unlike structs, JSONs actually similar to structs, JSONs also have key value pairs. However, these keys always have to be strings. So in Swift, you can see that we sort of declare a variable or a constant, and then we set a tape to it. However, in the case of a JSON string, all of the sort of type names, like age, classes, major, and name, those are actually strings, followed by a colon, as well as their values. So those values can be a number, a string, whatever data type, as long as you can convert it to this JSON format, or there's some way you can encode it into this JSON format. That value can be of any type as long as you specify that encoding. However, all the keys, so age, classes, major, and name, those have to be in string format. So how you directly sort of make that translation is that all sort of the constant names are the key strings, and all the values are the values in the JSON string.
Okay. Before I move on to a quick demo of how to use Postman, are there any questions about HTTP requests? Okay. So I'm going to move on about a demo for Postman. Most of y'all probably don't have it installed yet, so it's okay if y'all don't have it installed for this lecture, but for assignment 3, you will need to install Postman. So basically, like Richie mentioned, the two kind of requests that we're going to be using in this course is a GET request and then a POST request. And so when we want to read information, retrieve information from the backend, we typically use a GET request. So I created this endpoint right here when I wrote the backend. And what I'm going to do is, I'll show you how to create a request. So if you click on like one of these 3 dots, click add request, then you can, call it whatever you want. And then you just kind of want to type in the URL right here. So I went ahead and already created that here. So what I did was I created a GET request given this endpoint. Now what is this going to do? Well, I don't know yet. So I'm going to hit send. And so right now, it gives me a JSON. So remember, we use JSON to communicate between the front end and the back end. We use a JSON, and then this response, so the server responded with a JSON. Now notice how over here, the error code or the status code is a 200. In our world, if there's a 2, then that means we're good. So we successfully retrieve this information from the backend. Now, what about a post request? So over here, I created the same endpoints, but this time it takes in a post request instead of a GET request. So when we use a post request, we're giving data to the backend. So let's say I want to add, so right now, I believe this is a little bit outdated, but Caitlin isn't in the roster. And so what I'm going to do is add her to this roster. So then again, when you provide a request body to the backend, you typically provide it in the form of JSON. So what you want to do is go to body right here, change it to raw, and then originally it would be text, but then you want it to be in JSON. So we're sending a JSON to the backend, and then the backend responds with another JSON. Okay? And so now when I wrote the backend, it expects these 3 fields: a name, a position, and a subteam. So let me just remove the subteam here and see what happens. If I try to hit send, the server responds with an invalid request body, and then it gave me an error code of 400. Now, if you recall, a 4 means that the client did something incorrect. So now let me try to do something correct, which is by providing the backend what it needs. So I'm gonna add Caitlin. She's gonna be a member, and her subteam is iOS. Now let me try to run this. Now the server responds with a 200 status code, which means that the request is good. And so what did the server respond with me? Typically, whenever you're doing a post request, especially a create operation in which I'm creating data in the backend, it usually responds with the data that you created. In this case, I created this data right here, and the server responded with that data. So now, if I go back into the GET request area, if I hit send, if I scroll all the way down, now we see that Caitlin is now a roster here. If you're actually interested in like how the backend will look, I just created one with Firebase, and you can see that all this stuff is here. Okay, are there any questions about how to use Postman? Okay, so now we're going to go into this topic more front-end related called a callback. So this is like one of the most confusing topics that students tend to struggle with. I remember I struggled with this when I first learned iOS, but hopefully after today's lecture it will become more clear. So think about it this way, right? Open up Instagram or whatever app you have. Open up Eatery, for example. Sometimes the data doesn't load right away. Okay, so what is the issue with that? Well, that's because it depends on your network request, right? If you're chilling in Duffield, obviously you know how trash the Wi-Fi at Duffield is. It typically takes a very, very long time for you to receive a response from the backend. So let's say I were to open Instagram in Duffield. Usually it takes a long time to load. Now, because the speed of what you receive that response, because that response time can vary, you typically want to create network calls that are asynchronous, meaning that it's happening in the background. And we want to do this asynchronously because we don't want our app to freeze. Now imagine if you open Instagram and while things are loading, the UI just freezes, right? We typically don't want that. We typically have like some kind of cache system, and while the cache is being loaded in the background, this network request is being fetched. And because we don't want our app to freeze, we tend to create calls asynchronously. Now, because we don't know how long it will take, we want to be notified whenever we do receive a response. In other words, in our app, we can still do whatever we want, but as soon as I receive a response from the backend, I now want to process that data. So how do we know when that request is done? In our front-end world, we typically use callbacks. There are other ways you can use like async awaits if you're familiar with JavaScript, but a more traditional approach would be to use callbacks. Now, what is a callback? Well, a callback is simply just a function that you pass into another function as an argument though. And that function is being called as soon as the original function completes. I know I just said function like 10 times there, but it'll make more sense once we see the code. And then again, in Swift though, these callback functions, we typically call them completion handlers. So if I say completion handler, if I say completion, or if I say callback, those mean the same thing. So now let me just kind of quickly give y'all an analogy about, how does a callback work? Now say for example, my roommate, I'm out of town, and my roommate lives in my house, and I have a gift that I ordered from parents, but I'm unable to give that gift to my parents because I'm out of town. So pretend I'm the original function. I tell my friend, who is going to be this callback, to deliver that package to my parents whenever he receives it. Now my friend can do two things. He can be dumb and he can wait at the front door forever and not do anything and wait until the package comes. But then again, no one wants to do that, right? You want to wait until you receive that package and then you deliver. So that right there, my friend, he is a callback function. He's doing it asynchronously. He's waiting for the package to come, and then he delivers it to my parents. He's not going to stand at the door and then just stand there and wait and do nothing. I guess a more simple example, like imagine a phone call, right? You can tell your friends, call me back whenever you get some message. Right? You don't want to stay on the line and then wait for them for forever because you don't know how long it'll take. You want them to call you back whenever they get some kind of response or whenever they're ready to call you back. Does that make sense? Okay, so now let's translate that idea of callbacks into actual Swift code. So what I did here is let's consider some kind of social media app that contains a post object. So in A3, you will be dealing with post objects. So now you're going to be creating some kind of function. For example, this function is called fetch feed. I'm fetching my feed, which is an array of posts. So remember, a callback is just basically a function that's passed in as an argument. So this original function contains this argument contains this parameter whose name is called completion. I can call it whatever I want. I can call it completion handler or completion, but typically we want to call it completion because that's just the convention. So this parameter has a name called completion, and now what is its type, right? Remember when we create parameters, we also have to give it a type. Its type will be a function, right? Because it is a function. So it's a function that takes in an array of posts, and then it does not return anything, so it has a return type of void. Now, it may be confusing, like why is this callback not returning anything? Shouldn't it be returning an array of posts? But that's because when you're passing in information to a callback, you're passing it through the function parameter. You're passing in as an argument to the callback. The callback isn't returning anything. You're passing to this callback function through the parameter. So now, how will this work? So now let's say we create an array of post object. Now, how you want to do this is create some kind of HTTP request to the backend. So now because we're receiving information from the backend, we want to use a GET request. So, for example, we'll create a GET request to receive all of these posts. Now, after that response is done, if it is successful, then I receive that data in the form of a JSON. Now, because that's in the form of JSON now, I want to be able to use it in my app, so you can decode a JSON into your struct. But then again, if that were to fail, then typically in the second step, you want to have proper error handling so that you can know what went wrong. Either it was your fault or there's something wrong with the backend. Okay. Now, after that backend response is handled, let's say you do receive that data, then you want to assign it to this post variable. Now, you assign it to this post variable, but then you want to notify the original function that this callback is done. So this function is being ran, but then you don't know how long this callback will take. You don't know how long this network request will take. So what you do is you mark this completion handler as at escaping. That means after this function dies, so after you call this function, then this function gets erased from the call stack. However, this completion handler function, this callback function, still lives. That's what at escaping means. It means that it's able to outlive the function that calls it. Now, because it's able to outlive it, you then pass to that function the array of posts that you receive. So once you receive that data, then it calls this completion handler or the callback, and then you can actually handle your data. All right, I know that was a lot. So do any of y'all have any questions? All right, sounds good.
Okay, so like I mentioned earlier, before we sort of are allowed to, or are we able to connect our front end to our back end or make any requests, we first have to convert our data into a JSON format. So how we do that in Swift is we actually use this predefined protocol called a Codable. So there are two protocols that you really need to conform your model to, and that would be decodable and encodable. And these two protocols allow us to convert our Swift structs into JSON in order to send that to the backend. We can't just straight up send a struct because whatever backend is interpreting that cannot understand a Swift struct. You have to format it in the form of a JSON string and then send it to the backend. So in order to do that, we need to conform all of our models that we want to use, so the post model in A3, we need to conform that to Codable, which consists of both encodable and decodable. So yeah, commonly we use the Codable instead of the separate ones because Codable covers both of them. And yeah, in the scope of this course, we won't really be going too much into custom decoding and encoding. We'll sort of give you, there is a custom class that sort of does that for you. So I used to go more into more detail about how Codable works. So we have the student model here. This is something that you might be familiar with the Swift struct. In this case, for A3, this would be the post. And this is the JSON format to that. Essentially what Codable allows us to do is that it allows us to encode our Swift struct into JSON and then send that into the backend. However, let's say we get information from the backend. Someone sends a message and we want to fetch that message, fetch that post. So we want to actually decode that JSON into a struct. So what Codable allows us to do is use a decoder to decode our JSON string into a proper struct that we've defined. And using that struct, we can sort of use that struct and sort of how you've defined it with like the collection view cell and everything that is attached to the struct, you can sort of format that JSON data into the form of that struct. So remember in A3, we have an array of posts. Sort of when you get information from the backend, you'll get a JSON string. And from that JSON string, you can convert whatever data you have there into an array of posts, and that'll actually appear on your collection view once you've configured everything. So that's why we want to use the Codable model, because it allows us to decode and encode into JSON, which allows us to connect sort of our iOS front-end code to the back-end code. Yeah, so specifically, we probably cover this in the next lecture a little more, but specifically decoding and encoding. To decode, we use something called a JSON decoder, which is a built-in class into Swift, so you don't have to worry too much about that. And in terms of encoding, that process is sort of done manually through the request itself, so you would break down your struct and then send that data in the form of a request. So also to keep in mind, throughout the course, we've been using camel case to write all our variables and and everything like that. So keep in mind for JSON, we strictly use snake case, and this might be confusing when we're converting from the name here to the name here, but we'll sort of cover that in the next lecture on how we can convert from camel case to snake case without doing it manually. So keep in mind, camel case is for iOS development for Swift, and when we're actually converting to JSON, we want to use snake case, which is with the underscore.
Okay, so I guess before we move on to the Kahoot, I kind of want to quickly demo how to use Postman in case y'all watch this video later on for A3 specifically. So in the assignment handout, I do provide y'all with a table containing a bunch of endpoints as well as what the request body expects. And so, for example, if you want to fetch all posts, then you want to use this endpoint followed by /API /post. So if you go over here, /API /post, if I hit send, then right now, how we like kind of guided y'all with A3 is that right now you're creating dummy data, but we made sure that you create your dummy data based on this type of JSON that you receive. Now, one question that we received a lot is, well, the JSON represents time as a string though, but you said you want us to represent it as a date object in Swift. That's because the decoder allows you to convert this kind of string, which is a common format you receive, and then be able to convert that into a date object that can be used in Swift. And so whenever you're creating your time property, just make sure that it is a date object. And then again, so this is like a list of post objects in which the post object contains these fields. And then what I can also do is create a post. So I can say Halloween. And then if I hit send, remember you want to use raw and then JSON. And then hit send, and now the server usually responds with this data. Now in 8.3, you might not do anything with this data. You probably won't, but then again, remember it gives you a 200 error code, or in this case, a 201. So a 201 just basically means that you created something. And so what you can do is that whenever you're handling this kind of request, if it's successful, then you're good to go. Otherwise, if it's not successful, then you throw an error. But you don't really have to do anything with this data. So now if I were to fetch all posts again, you can now see that there's a post object here for the one that I just created. You can also like and unlike a post. So whenever you like a post, let's say this Halloween post I created, it's going to have some ID. And so let me pass that in here. And then what you want to do for your assignment is pass in your net ID for the request body. So let's say I put VDB23. If I hit send, now if I fetch all posts, you can see that now I've liked this post right here. And then you can also do the same thing with unlike posts. I don't remember if this was extra credit or not, but the assignment handout should point that out. And then these don't, this is for the admin. Okay. Are there any questions about using HTTP requests? Yes.
So like for A3 and like the date object for time, do we convert it from that string to the date object in like the configure method, or where do we do that?
Yeah. So basically, whenever you after Wednesday's lectures, it will make more sense. But when you're writing your code, you want to decode it with the JSON decoder. And then you basically how the decoder works is that it sees a string for it and it sees it in a valid format. And so it allows it to be decoded into a date object. But whenever you're representing in iOS code, you want to use a date object. And so whenever you're creating your dummy data, to create your date object,
Sorry about that. I left my AirPods.
you would use date followed by 2 parentheses to create the actual date object. Okay. Are there any other questions? Yes.
In the backend, how do they represent the list of likes? Because, what if you had a lot of likes? Do you have to, search through it and know every time?
Yeah, that's actually a really good question. So I guess, so this is for the lecture for Wednesday, but I can show y'all. So I use Firebase for it, but then most servers typically have an actual database. You can use MongoDB, Postgres. There's a bunch of SQL databases out there, or even NoSQL databases. That's more backend specific. But how I do it is I use Cloud Firestore. So right here, I have a collection of post object. And so let's say, let me create another post. Hi. Hit send. Now you can see that it automatically generates that in the backend. And so how I wrote it, whenever you, fetch all posts, is that it basically looks through all of this, and then it returns it in the form of a JSON. That's more backend related. If you're interested, you can always, take the backend course as well.
As specifically, you were asking how the likes were displayed in the backend, right?
Yeah, because you can store multiple values.
Yeah, so typically you would, in this case, we're actually nesting them within the actual post object itself. So within post is actually another sort of array that represents the people who liked it. Another way you can sort of do this that sort of saves more space is using a relational database, which is, again, beyond the scope of front-end development, but in terms of back-end development. allows you to sort of relate to databases rather than nesting them.
Yeah, that's just more backend related, but yeah. Any other questions? All right, so we're gonna move on with the Kahoots. First question. True or false? A collection view can be horizontally and vertically scrollable. Yes, that was quick. Yeah, so a collection view, you can scroll both horizontally and vertically.
All right, next question. Which of the following functions do we need to implement when using a UI collection view? Ooh, it's a tricky one. So in terms of wording, this might be a little tricky because for a table view, it is self or row at. However, for a collection view, we don't really have rows because they don't really matter because we can have items. In a collection view, what we configure is the self or item at. So that's the distinction there. Same thing with height and number of rows in section. Those are table view functions. However, the one thing that we do have to implement in a collection view is the size for item at, which specifies the size of the cell that we want. All right, let's see. Oh.
A UI table view needs a flow layout. Yeah, so the answer is false. Only a collection view requires a flow layout because you can have multiple columns, whereas a table view, you can only have one column. Okay. Nice, good job, AI259. Okay, while y'all pack up, we're gonna end it a little bit early today, but just a quick, some to-dos. Again, A3 is due tomorrow night. Try to get CocoaPods set up by then, but then again, you don't really need CocoaPods until after the midpoint submission. Remember, it is for completion, so please at least put in some effort. We will give y'all feedback though. Okay.